Welcome back. Now, we've explained the summer synoptic chart conditions. Just to quickly recap, most importantly, pay attention to your date. Indicate summer overlay. Secondly, there's a low pressure system over the interior. It's warm conditions, rising air. Thirdly, go to your actual weather station models on your synoptic chart. Now, what you will see is you will usually see high temperatures. And thirdly, your South Atlantic high pressure and your South Indian high pressure. The South Atlantic high pressure has migrated towards the north, and your South Indian high pressure has migrated northeast. As you can see, there's no Kalahari high pressure system over the interior. Now let's just quickly go and have a look at our winter synoptic charts. Now in South Africa, especially the Western Cape and the interior, we experience cold front conditions. So that's one characteristic that we can go and have a look at. Secondly, the Kalahari high pressure system. Thirdly, the date, exactly like the same that we did with the summer synoptic chart. And then again, we can go and have a look at our South Indian high pressure system and the South Atlantic high pressure system and the way they migrated during the seasons. Now, obviously, as you know, during winter, if we look at our daily temperatures, we will expect that we experience quite low temperatures, cool conditions. Now, let's go and have a look at the synoptic chart. Our first clue over there, July 23rd, 2011. So, as you know, obviously, we experience winter conditions, season of winter. Now, secondly, like I've mentioned, we experience mid-latitude cyclones, cold fronts. Now, as you know, cold fronts creates very cold conditions in the interior of South Africa, and it provides rainfall for the Western Cape area. So that's our second clue that we have over there. Our third clue, we can just go and have a look at the weather station models of Pretoria situated over there. As you can see, Pretoria experienced a low temperature of only 20 degrees Celsius. And very importantly, if you look at the weather station model, there's no cloud cover whatsoever. The reason why we don't have experienced any cloud cover over the interior of Southern Africa is because the Kalahari high pressure system is situated over the interior. Now, what do we know about the Kalahari high pressure system? What do we know about high pressure systems in general? First of all, we've learned that it's sinking air. And when air sinks, it's usually because of cold conditions. As you can see with the South Atlantic high pressure system, it has migrated towards the south. And later on, we will have a look at the influence of it. Now, the South Atlantic high pressure system has migrated towards the south. Now, this to the north. So basically what happens, that's the reason why mid-latitude cyclones have a severe effect on South Africa's climate during winter. And the South Indian high pressure system has also migrated towards the north during the winter. Now, in the exams, you need to be able to distinguish between both of them. Very importantly, you need to be able to identify your weather station models. Now, I just want to do a quick example for you with a weather station model. Now, very importantly, grade 12s, you need to be able to describe the weather of a place. Now, if I give you the following information, let's say, for instance, we experience air temperature of 24 degrees, we're experiencing dew point temperature of 18, we're experiencing thunderstorms, we experience wind speed of up to 5 knots, we experience wind direction in a, let's say, southeast direction, and we experience cloud covers 3/4. Now, if this set of information is given to you during the exam, you need to be able to go and draw your own weather station model. Always start with your cloud cover, the body of the weather station model. Now 3/4, you go and look at your references. Then start with your temperature. As you can see, the air temperature is 24 degrees Celsius. The dew point temperature, again Gr12s, please remember, it's not minimum temperature. Dew point temperature is where condensation takes place, is 18 degrees. The type of precipitation that we might experience during the day, or are experiencing during the day, is thunderstorms, and the symbol for thunderstorms looks like that. Our wind direction is southeast, and our wind speed is 5 knots. Now this is how you draw a weather station model, and if you need to describe a weather station model, once again, refer to your temperature. It's 24 degrees Celsius. It's 18 degrees dew point temperature. We're experiencing thunderstorms. We have 3/4 cloud cover. The wind direction is southeast, and wind speed is 5 knots. Okay, now that you need to basically learn how to draw a weather station model, always keep in mind, describe the weather according to the station that you've drawn or that you need to be able to get the information from. Now, Gr12s, it's a guarantee that you will get a summer synoptic chart or a winter synoptic chart in your final exam. Most importantly, the biggest clue is your date. And obviously look at the temperatures of your weather station models and look at your atmospheric patterns, for instance, low pressure systems and high pressure systems that develops during summer and winter. Winter, same scenario. In South Africa, usually experience cold fronts. The Kalahari high pressure system is over the interior of southern Africa. An easy way to be able to identify that, once again, when you look at your weather station systems, weather station models, pardon me, you will see that it's clear blue skies. Why clear blue skies? Because of sinking air. Keep in mind, Gr12s, clouds can't form when it's sinking air. Clouds formation takes place with rising air, and it's usually the rising air that cools down, it condenses, and we got cloud formation taking place. And a straight giveaway, once again, go and look at your low temperatures. There's the synoptic chart that we discussed. As you can see, the Kalahari high pressure system is over the interior. The date is a date giveaway, and you can go and have a look at your temperatures. That's quite low. Now, our next topic that I want to discuss with you, we did it in grade 11, global air circulation. Now, global air circulation is very important to understand the movement of air. Now, before I'm going to start this topic, air moves in two ways, horizontally or vertically. When it moves vertically, we look at low pressure systems and we look at high pressure systems. When it moves horizontally, we look at wind. It's known as wind. Now, what is wind? It's basically that air moves from a high pressure to a low pressure. And we know if air moves vertically upwards, it's known as a low pressure, and where air sinks, it's known as a high pressure. Now, with the synoptic charts, what do we know about low pressure system? It's rising air because of warmer conditions. We know it's rising air because it's being forced to rise. But you know about high pressure systems? It's sinking air because of cold conditions. And very much importantly, air moves from a high pressure to a low pressure, and that is known as wind. Now, we experience different types of pressure systems all around the world. And the simple reason why we experience them is because of the different insulation that the surface receives. Now, in grade 10, you've learned about insulation, heating of the Earth's surface. Insulation stands for incoming solar radiation. Now, obviously, different parts in the world warms up and is warmer than other parts of the world. And we're going to have a look how it influences the different pressure systems that we experience all around the world. Now, first and foremost, let's go back to the basics. In grade 10, like I've mentioned, you've learned about insulation. Incoming solar radiation from the sun. Now, obviously, radiation heats up the surface of the Earth. Now, obviously, the shorter the distance that these sun rays travel from the sun, how warmer it's going to be. How further it needs to travel, how colder it's going to be. Now, as you know it, if you look at the equatorial regions, basically the warmest conditions that we experience on the Earth's surface. And where do we experience the coldest conditions on the Earth's surface? Yes, the polar regions, over here. The simple reason for it is because the insulation from the sun is the greatest distance between that and the sun. And obviously, if you look at the equatorial regions, experience the warmest conditions because the insulation travels the shortest distance to this region over here. Now, immediately, what type of pressure do you think we experience at the equatorial regions? Now, keep in mind, very warm conditions, lots of insulation. What type of pressure are we going to experience? A low pressure. At the polar regions, now you've seen it on TV, if you look at the polar regions, South Pole, North Pole, it's usually covered with what? Ice and snow, right? So what can we say? We experience very cold conditions. Now, if you think of equatorial regions, you usually see the Amazon jungle, warm conditions, tropical waters, tropical jungles, etc. And if you look at the polar regions, very cold conditions that's associated with snow and ice. Now, immediately, what can we establish? At the polar regions, we experience high pressure systems. And at the equatorial regions, we experience low pressure systems. After the break, I would like to discuss the global air circulation in detail with you.